Control Systems Engineer Job Role, Practical Experience Guidelines and AI Contribution. Welcome to the world of control systems engineering, where technology meets innovation. Our engineers design and implement sophisticated control solutions, integrating AI also automation to power industries of the future. From ensuring smooth operations to enhancing safety, they play a crucial role in shaping a more connected as well as efficient world. Explore the journey of a control systems engineer and discover how you can contribute to smarter industries along with a sustainable future. Job description: Control systems engineers design, develop, and maintain systems to control processes, also machinery efficiently and safely in various industries. They integrate software, hardware, sensors, as well as actuators into automation frameworks, ensuring the systems meet performance along with safety requirements. Industry profile: Control systems engineers are essential across industries like manufacturing, oil and gas, energy, automotive, aerospace, robotics, also smart infrastructure. With Industry 4.0 as well as 5.0, these engineers focus increasingly on automation, AI-based predictive maintenance, including cybersecurity in critical infrastructures. Key responsibilities: System design, develop control algorithms, logic diagrams, and automated systems. Implementation and testing, deploy systems in the field, also conduct performance evaluations to meet desired outputs. Optimization, analyze as well as optimize control loops for energy-efficient operations. Integration of AI, implement AI models for predictive maintenance along with real-time data-driven decision-making. Safety compliance, ensure all designs meet safety standards such as IEC, ANSI, and ISO. Collaboration, work closely with cross-functional teams, mechanical, electrical, including software engineers. Troubleshooting, resolve system malfunctions, also perform root cause analysis. At a glance: your interest. Problem solving, automation, and software integration in industrial systems. Entry qualification: bachelor's degree in electrical, mechanical, or control engineering. Lifestyle: mixture of office-based design work, also site visits. Some roles require traveling for system deployment as well as troubleshooting. Location: found in industrial areas, manufacturing plants, or project-based environments, including energy plants and refineries. The realities: involves high responsibility for system reliability, working under pressure during breakdowns, and continuous learning to keep up with evolving technologies. Soft Skills Guide: work effectively in multidisciplinary teams with diverse expertise. Led technical teams and projects, providing direction, also motivation. Apply logical problem solving to complex control systems. Master software tools like MATLAB, PLC programming, as well as SCADA systems. Understand client requirements to design cost-effective solutions. Career path: trainee. Join as a trainee to understand control principles and industry standards. Graduate engineer. Work on real-world projects with experienced engineers. System analyst. Analyze existing systems to identify optimization opportunities. Automation engineer. Specialize in automating processes with advanced controls. Technical architect. Design the entire system architecture integrating hardware and software. Project manager. Manage end-to-end projects with a focus on timelines, budgets, also team coordination. Consultant engineer. Offer specialized advice to improve automation in various industries. Related careers: automation engineer, focuses on automating machinery and processes. Electrical engineer, works with electrical systems used in control frameworks. Software engineer, develops software for process monitoring, also control. Systems architect, designs control systems at the architectural level. Process engineer, optimizes processes within the control framework. Here's a list of the following practical experience for control systems engineer and how to learn it with latest or updated technology. PLC programming, programmable logic controllers. Description: develop, test, and deploy control logic for automated systems. PLCs are widely used in industrial automation. How to learn. Courses and certifications: Siemens S7, Allen Bradley, Mitsubishi PLC training programs. Software tools: TIA Portal, ARIS-Logix 5000. Hands-on practice: use simulation software like Factory I/O to practice coding logic. SCADA systems, supervisory control and data acquisition. Description: design and manage SCADA systems for real-time data acquisition and remote control of industrial processes. How to learn. Courses and training: SCADA with Wonderware, GEI Fix, or Ignition by Inductive Automation. Practical projects: work on sample projects with open-source SCADA software. Workshops and webinars: attend industry events focused on SCADA systems. MATLAB/Simulink for control design. Description: use MATLAB and Simulink for simulation, modeling, and control system design. How to learn. Training programs: MATLAB also Simulink Fundamentals course on MathWorks. Practical experience: develop as well as simulate models, such as PID controllers or motor drive control systems. Community: participate in MathWorks user communities for support including collaborative projects. Industrial networking, Ethernet/IP, Profinet. Description: set up and manage communication protocols for industrial automation systems. How to learn. Certifications: Certified Industrial Network Specialist, CNS. Tools and labs: use hardware like switches, also routers, and virtual network simulation tools such as Cisco Packet Tracer. Online resources: study materials on Profinet, Modbus, as well as OPCUA available on vendor websites. PID controller tuning. Description: implement and fine-tune proportional integral derivative controllers for system stability. How to learn. Courses: Advanced Control Systems courses on Coursera or edX. Practice: use software like MATLAB, LabVIEW, or Python for control system simulations. Real-world projects: experiment with DIY control kits or laboratory process simulators. AI and machine learning for predictive maintenance. Description: integrate AI models to predict equipment failures and optimize maintenance schedules. How to learn. Courses: AI for Industry, also predictive maintenance on Coursera or DataCamp. Tools: TensorFlow, PyTorch, as well as Python libraries for predictive maintenance models. Practical implementation: work on datasets from platforms like Kaggle to develop predictive models. Robotics and motion control systems. Description: design and program control systems for robots, including servo motor control, also trajectory planning. How to learn. Courses: robotics specialization on Coursera or ROS, Robot Operating System, tutorials. Tools: use ROS, Arduino, as well as Raspberry Pi for practical experience. Projects: build robotic arms or drones with control systems to reinforce learning. Cybersecurity in Industrial Control Systems, ICS. Description: protect control systems from cybersecurity threats. How to learn. Courses: ICS/SCADA cybersecurity courses on Cybrary or SANS Institute. Certifications: Certified SCADA Security Architect, CSSA. Labs: use virtual environments to simulate cybersecurity incidents and mitigation. HMI, Human-Machine Interface, Design and Configuration. Description: develop user interfaces for operators to monitor and control processes. How to learn. Courses: training on Wonderware InTouch or Ignition HMI software. Practical projects: build basic HMIs using Ignition Designer. Community engagement: participate in forums and GitHub projects related to HMI design. Project management for control systems projects. Description: manage project timelines, budgets, and teams for control system deployments. How to learn. Certifications: PMP, Project Management Professional, or Prince2. Tools: Microsoft Project, Trello, or Jira for project management. Case studies: analyze successful automation project implementations to understand best practices. These experiences reflect the current demands of the control systems field and align with the latest technological advancements. By combining theoretical learning with hands-on practice, aspiring control systems engineers can acquire relevant skills to excel in this evolving industry. 8. A contribution to autonomous transformation for control systems engineer role. Thank you for listening. For more information related to career path, job role, or description, follow our channel Career Quest.